You internet people out there frequently leave comments asking for some clear direction to get started in metal casting. Here's one. I have a 3D resin printer but never done any casting. For me it would be awesome for a video on how to get started with metal casting, such as the tools and maybe where to get supplies. A year ago I made exactly that video, which got pretty good views and then was memory holed by the algorithm. It needs an update anyway. So today we're going to walk through an updated list of the equipment you need to get, and then I'll show you the next steps to take after that. And I'll splice in a bit of past me wearing the same shirt when he has something useful to say. There are multiple ways to cast metal and they're all awesome. I'm going to focus today on sand casting. In my opinion, if you don't have a dire need to do something else like investment casting for jewelry or whatever, I'm going to suggest you start with sand casting. First, you need something to cast. This comes in the form of a pattern. Pattern is the thing that you make that isn't metal that you use to make the hole in the sand mold into which you pour the metal. Do you follow that? I have used wooden patterns in the past. Here's one. It worked out great. Wooden patterns have worked perfectly fine for centuries, and they certainly will work forever into the future. But I don't want to tell you to start sand casting by learning woodworking first. Unless you already do woodworking, then go nuts. I love woodworking. It was the first maker thing I ever did. It might be easier for you to start with a 3D printer, resin or FDM, they both work, 3D model or download a file and then print that. I don't have time to like carve all the little details in this sign, but I can 3D model it very quickly and then print the thing out of my sleep. People get 3D printers, right? And they make a bunch of cool plastic stuff, and then other people look at it and say, well, that's cool, but it's only useful for making plastic trinkets. No, it's not. No, it's not. They are very much useful for more than that. That aluminum bronze forging hammer that I made years ago, sand cast from a 3D print. The aluminum bronze spear that I also made years ago, also sand cast from a 3D print. My little shop sign here in bronze, sand cast from a 3D print. But I get it. Finding equipment is a bit overwhelming because it's scattered all over the place. You don't know what to get. You don't know where to get half of it. You're like, what is that? What's that called? Why are you doing that? But we're going to simplify all the equipment today. What are you going to need? Well, first, you can't sand cast without sand and something to put the sand in. This is a very simple way to start. You can buy this. This is called a flask. It has two pieces. This you can use vertically. You don't have to build it from wood. It has little locating pins, and you can buy it with a kit. It comes with 10 pounds of Petrobond sand. Petrobond, the red sand. If you watch videos and see they're using like a red looking sand, that's Petrobond. Petrobond is an oil bonded sand. I personally like it because it's really sticky, which you want in a casting sand. And unlike green sand, which is the main alternative, green sand is a water bonded sand. You don't have to worry about moisture. I can leave it in an open bucket for 5 years and it will not dry out. In fact, it'll be just as good the very next time I go to use it. I have never once had to worry about moisture, and Petrobond gives you really nice detail. If you're just gonna get started, just buy a bag of Petrobond. Now it's sticky, and you're gonna need something called a riddle. A riddle is a tool that you pass the sand through to just break up the clumps, especially when you're first like putting the first layer of sand down. A riddle is not a special fancy tool that you have to pay $1 million for. Here's mine. It's a metal kitchen sieve, and it is wrecked. I need to buy a new one, or I just need to go into the kitchen and steal another one. That's where I got this one. It looks like it's maybe 16 mesh. I'm not sure. It's fairly coarse sieve. You can see I've pushed a bunch of sand through there. So if you ever see people taking the sand in the videos, putting it through and either shaking, you can't really shake Petrobond through, you have to push it through. That's why we call it a riddle. You can call it a strainer, kitchen strainer. You probably have one that you can just swipe out of the kitchen. Next, you need parting powder. All of the stuff I have at reach. I've been using this. Now this is Johnson's baby powder, and it's a very old bottle of Johnson's baby powder, which means this is talc. Modern baby powder is not talc. It's generally cornstarch. Cornstarch does not work. So instead, you go on Amazon and you look up parting powder. You can get a couple pounds of it. It's gonna say non-silica parting powder. That's important because traditionally foundry workers used silica powder, which is glass. Finely powderized glass, and that is murder on your lungs. You might as well be breathing asbestos, right? You don't want to breathe any parting powder, obviously. Asbestos and silica are really bad. You can get parting powder now, foundry parting powder designed to work with Petrobond on Amazon now. Next up, a dross scooper. When you watch metal casting, you might see the crucible with the molten metal in there, and there'll be like a skin, or there'll be a bunch of grime on the surface of the liquid metal, right? And they usually take some kind of scooper and they scoop it off. I've been using this, a scavenged stainless kitchen spoon. I clamp it on the end of some vice grips, wear a big leather glove, and just scoop the crud off the top. Now, I'm gonna show a picture of one that's a stainless steel spoon. It's a very small end and a very long handle. And the reason for that's going to be obvious in a little bit when we get to the melting furnace. The larger your crucible is, the bigger the end of the scoop can be. But if you're just starting out, I suggest you start small. Next up is an ingot mold. I have a couple here, they're different sizes. These are graphite. When you melt metal, you often melt more than you need. You definitely don't want to melt less than you need, right? And you need some place to pour that because you can't leave it in the crucible. I usually pour them into ingot molds like this. I like the graphite ones because when the metal cools, when it's cold, you just pick it up, tip it over, ingot falls out. If you try to use like the muffin tin ingot trays and you pour bronze in there, the bronze will braze itself to the muffin tin. That's not good. It will not braze itself to this. Also, these ingots are very small, and that's important. You will see soon when we get to the furnace. Speaking of furnace, if you're new, I will suggest you start with one of these. This is an electric furnace. I've shown it a bunch. It's been in a bunch of videos. You program in your temperature, and it takes you up to temperature, and then it holds it right there. It's really nice. You don't want to use one of these to break down like scrap. Like if you're melting down scrap, this probably isn't the right one for that. You want to use a propane one for that. But propane one is difficult. It adds more complication. You have to get the fuel mixture right. It's difficult to maintain the right temperature. You can overshoot or undershoot very easily. This is the smallest crucible for this thing. This melts 1 kilogram, 2.2 pounds or so of copper. And that's a lot of bronze. Most of the things that I've made, that big aluminum bronze hammer was only 2.2 pounds. And you notice here, that's small. Your draw scooper, if you need it, needs to fit in that opening. And if you make ingots with the extra metal, that ingot has to be small enough to fit through the opening. See, it's all coming together. I recommend if you're new to this, start small like this. You don't want to learn new things, right? When you're holding 6 kilograms of bronze molten on the end of some crucible tongs. This is a very good kit because it comes with the furnace, 2 crucibles, tongs for the crucibles, and leather gloves. There are some gas furnace kits that seem pretty good. They're made by a company called Devil Forge. Now, disclaimer, I have never personally used a Devil Forge product, but I've heard good things from people I trust. My gas furnace was built by me from scratch. That includes the burner and my crucible tongs. I learned a lot of things about a lot of things building that, chiefly among them how bad of an idea it is to build your own thing from scratch when you can buy one for cheaper. I probably spent triple the amount of money it would cost to just buy one, and my setup, especially the burner, is a little like, eh. I did not, however, make my own crucibles. The crucible is the thing that holds the metal. That also means if these break, this is the thing that the molten metal will pour out of. That's not good. Most of the discount gas furnaces come with crucibles that scare me, just from the pictures. And those vice grip tongs they tell you to pick it up, that is a fantastic way to ruin a crucible. Don't do those. The Devil Forge kit, the reason I like it and the reason I'm mentioning it at all is because the crucible looks a little better and it has tongs that actually like grab it from like around. I get my crucibles from a company called PMC Supplies. They do have an Amazon store and their own website. And the tongs I use wrap around. I made my own tongs, but if you find tongs that wrap around, that's for the best. And the electric ones, the electric kits, come with their own tongs that go in a groove in top of the crucible. That's what you want to use. Just keep in mind, none of them last forever. Crucibles are kind of wear and tear items. Don't overuse them. Don't overfill them, especially the ones for the electric furnaces. Learn that one the hard way. Now the metal. Where do you get the metal? Well, there's a bunch of places you can buy it. I'm going to link a few down below. Rio Grande is one. Here's some from Rio Grande. I've also purchased metal from a company called Rotometals, rotometals.com, and belmontmetals.com. They all seem like good places. This right here from Rio Grande. Rio Grande is a jewelry supplier, and you can get 5 pounds of ancient bronze, which is copper and tin, for less than 20 bucks a pound, which is cheaper than the cost of just like nice copper ingots, right? And it comes in this very clean grain. Ooh, shiny, shiny, shiny. Oh no, I dropped one. These pieces are super shiny. They're very clean. I think they include deoxidizers already because it flows really nice. I've never had any dross or any crud I had to scoop off from it. Anyway, that's how big the pieces are. That's useful because you can measure out exactly how much you need. And it's surprisingly cheap for how nice the metal is. Just make sure whatever metal you get, it comes in a form like grain or shot that fits inside whatever crucible you have. These days you can get a zinc alloy in small chunks that fit in the electric crucibles. You can get those from Rotometals. This is the way I used to buy a ZA12. It's giant. This barely fits in even the larger gas ones. It's too big. But now Rotometals sells them in this size. See, considerably smaller. This will fit in an electric crucible. This is especially awesome because bronze is a very high temperature metal, Bronze is a little cooler looking in general, and it's a bit more hardcore, but it takes an extra 1,000 degrees, which is more energy, more wear and tear on things. You know what I mean. If you want a side-by-side comparison, this spear is ZA12, this spear is ancient bronze. And then this is the 3D printed pattern that I used to make it. I also had like a giant one somewhere, which I cast and have since lost. I get it, my garage is messy, all right, I know. Anyways, ZA12 might not be as traditional as ancient bronze, but it is my favorite casting metal right now, and it melts at a cool enough temperature that doesn't even burn the Petrobond. Like, it's just fantastic. Now, printable parts. There are some tools that you can't just go and buy. They don't have them in a hardware store, they don't have them on Amazon, but you have a 3D printer, so you can just make them if you get the right files. I will give you the files. This sand rammer that you've seen me use in many videos for many years was cast from a 3D print. That's basically how I do metal casting. Here is a printed version of it. I have used the printed version also as a sand rammer, and it works. You don't need to go all the way to making it in metal, but what, am I not gonna make one in metal? Of course I'm gonna make one in metal. Here's how they print. You can print them flat without support material on an FDM printer, and I've been told it fits on a Mars 3, possibly. It definitely fits on like a Saturn, Elegoo Saturn resin printer. You print 2, get some locating dowels in there, stick them together, you can use it like this. Or you use the dowels to help center them while you're ramming them up as a split pattern. I have the STL for this on my mini factory. Go nuts. Another tool, which you probably haven't seen much in a video, is a wrapping tool. This is what it is. If you have a pattern and it's got like, sometimes you put screws in and then you kind of pull up on the screws to help you get it out of the sand. Well, a wrapping tool takes that and you wrap it back and forth. It kind of jars it free and then it lifts out nice and easy. It's a very simple tool. It is probably not required. I didn't use one for years, but I got a file for one. Also on my mini factory, you can have it. Go nuts. Next, I have some gating tools. I use this to form something called a pouring basin. This is a tapered sprue former. I have runner formers. These can help you design the ways that the metal go through the mold. You want it to be, you know, nice gentle curves, not a lot of turbulence, don't suck a lot of air in there. Spin traps, some people use those. All of my gating tools that I use are 3D printed. They're easy enough to 3D print. I don't have the files for all these available because the design of them really depends on the flask size and design. So they're very much more individualized, but if you make a flask and you design and print some of these, they're good for you. If you're using this small cast iron one, you really don't, do you really need a sprue former this big? It doesn't fit, that's what I'm saying. Now, there are also a couple of things that you can just find probably around your house. First one, 2 socks. Get a pair of socks. No holes. Take one sock, stick it inside the other sock. Then in the inside sock, the inner sock, fill that with your parting powder. The way you use that, you take the sock and you shake it over the pattern or whatever you need the parting powder on. It will come through the socks and distribute nice and evenly around the pattern. Nifty, right? 2 socks and the parting powder. Now to go with that, I would suggest swipe a makeup brush from your bathroom. I don't know how long my wife has been missing this, but here it is. Now this might be more important because I just spray the powder out of the bottle. But what I use this for is I move the piles of parting powder into nooks and crannies that I didn't get because this doesn't squirt out as easily as the sock shaking thing. One of these might be useful. Might also be useful for brushing loose sand away. Next up, a striking tool. Now that's when you're ramming up the sand, you get to the top and it's kind of lumpy. You need to shave it smooth. I use this. It's just a piece of angle iron. Probably use a ruler, metal ruler. As long as the tool is longer than your flask is wide, you can scrape the extra sand off the top. No special tool needed. You can also use a board. Boards don't work as well as angle iron. Then, lastly, you need a vent wire. Here's mine. It's basically just a TIG filler rod. I use this to poke holes through the sand, which allows air to get out more easily. If you're not into welding, you don't have a TIG welder with the filler rod you can swipe, go in your bedroom closet, find a wire hanger, straighten that out. You now have a vent wire. Using all of that stuff that I just said, you can start sand casting. You don't need thousands of dollars of investment casting equipment. You just need that stuff and you can do it. Once you get going, then you can scale up. Bigger flasks, more sand. That's about all you need. Bigger flasks and more sand to scale up. Everything else is the same. But now I hear you asking, okay, great. I can get all that stuff. That seems easy. I have no idea how to use it. How do I use it? Good news, I can help you with that too. I have an online course that teaches you how to use your 3D printer to learn sand casting. Module 1 is complete, where you go from being complete noob, total beginner, to having knowledge and some hands-on skills for all the basics. Module 2 is being built right now, where you take those skills from Module 1 and we build on them, basically to make things that are bigger and better quality, more complicated, you know. I call it a course. That's not exactly what it is. That sounds like it's just a bunch of videos like Skillshare or something. It's more than that. I actually help you like one-on-one. Just this week, I was helping a person figure out how to turn a complicated part into a match plate so they can cast multiple of the same thing for a multimedia project they're working on. It's really cool. The match plate image from earlier in this video was from that video that I made for that purpose for that person. If you want to learn all about that, it's in the course. There's also a community forum that's like a whole deal. Hopefully, I'll see you there. And stick around on YouTube. My next video will be sand casting some stuff from a 3D printed pattern, so that will be fun.